confidence interval. After that, when you understand what is confidence interval, then we'll go into hypothesis testing. And the two important points when you want to test your hypothesis is the p-value, and we will also discuss about the sources of error. So first, what's a confidence interval? So remember last week, we talked about estimation, right? We talked about how to use the sample statistics. How do you use the subsets of sample drawn from the entire population and make estimations on the population parameters? Okay, but so when you make the estimations in using your sample statistics, there is always uncertainty around that estimate because the number is based on a sample of the population that you are studying. Okay, so this is why we need to come up with a confidence interval, confidence level. Okay, so a confidence interval, as you can read from the name interval, is a range of value. Okay, it's not only one value, not a single value. So a range of value that you expect your estimates. So after you do the calculations, you come up with your sample statistics. That's your estimate. So confidence interval is a range of value that you expect your estimate will fall between this certain percentage of time. If you rerun your experiment again and again, or you resample the population in the same way. Okay, this is about accuracy. So no matter how you repeat your experiment, okay, in the same way, provided that is in the same way, but you draw different subsets of sample from the entire population, you are confident about that your estimate should fall between this range. So we call this range as the confidence interval. Okay, then confidence interval in the other way of explanation is that the percentage of time you expect to reproduce an estimate between the upper and lower bound of the confidence interval and is set by the alpha value. So later on we will learn what's alpha value. Okay? So confidence interval. So the mean of your estimate plus and minus the variation in that estimate. So you will get the range. Okay, you will have an upper value, you will have a lower value. So this is the range of value you expect your estimate to fall between if you redo your test within a certain level of confidence. So confidence level intervals also for you to describe probability. Okay, for example, if you construct a confidence level with a 95%, so what does that mean? So which means that you are confident that 95 times out of 100 times that your estimate, the sample statistic, the calculation that you do, will fall between the upper and lower values specified by the confidence level. Okay, so there is a simple formula for you to calculate your confidence level, which is 1 minus the alpha value. A is the alpha value. Okay, so actually A, we call it as alpha value, is the p-value that we learned in our last lesson. Okay, so let's say you want to set your confidence level at 95%. So which means that your alpha value will be 0.05. Your confidence level will be 1 minus, remember the formula, 1 minus the alpha value. So it will be 1 minus 0.05, then it will be 95%. So here's two distribution curve showing you what's the p-value. Remember, the alpha value is our p-value, the probability value. Okay, under the area that cover under the distribution curve. Remember what's p-value? Our last two lessons. Okay, you need to determine your p-value using the distribution curve, the area under the distribution curve. Okay, So we talk about confidence interval, but when to use the confidence interval. So actually, other than for the population mean to compare the mean, you can also calculate the confidence interval for many kinds of statistical estimates, which include proportion, the difference between population means of proportion, as well as the estimates of variation among groups. But in our basic biostatistics, we only focus on the calculations of confidence interval for population mean. Okay? So, just now, this is another slide, a diagram showing you what is the use of confidence interval. So we can see that there's a populations here, right? So if you get the entire data set, you'll get some, the histogram looks like this. This is your populations. So sample, the subset from a population, your histogram, your graph will look like this, right? But it will be normally distributed if your sample size is large enough. Remember the central limit theorem? So, because we are using the sample to estimate the population parameter, so we need to measure how good is your estimate is. So, this is why we measure the precision and confidence level. So, this is the confidence interval. Any question, class, before we go into the step-by-step how you calculate the confidence interval? All clear? So, it's very easy for you to calculate the confidence interval. You need to have 4 points here. First, you need to identify the population mean. Okay? Everyone know how to calculate the mean, the average. Okay? Then you will need to calculate the critical values. So later we'll go together how to come up with critical values. What's the critical value? Then you also need to identify the standard deviation of the sample as well as the size of your sample. Okay? So first, you need to identify the population mean. So let's say you have an example here. This is the survey that you carry out, your study. So you study 100 year 1 students and 100 year 3 students in some way, okay, about their television watching habit. And you find that both groups watch an average 35 hours of television per week. Okay, this is the total, this is the average. So you got your population mean. Okay. Then next, you need to identify the critical value. Okay. So, what's critical value first? Before you learn how to calculate critical value, you need to understand what's the critical value. So, critical value actually tells you how many standard deviation are away from your mean value. Okay, now you got your population mean. And then, look up the critical value that correspond with the alpha value. Okay, so do you all remember the central limit theorem? When you have large enough of sample size, your data will always be normally distributed. Okay, and then for that, you must perform the z-test. Z-test is the one that we did, the exercise that we did during the tutorial, right? What's z-test? Z-test is only one of the statistical tests. We have many statistical tests for you to test your hypothesis. Z-test is the one that we learned so far. Okay? Remember how to calculate the z-test? Remember how to calculate the z-score? Right, but once you got the z-score, then you use the z-table to find your p-value, am I right? So this is the z-test, or sometimes the research paper will call this as z-distributions. Okay, so if your study fulfill this criteria, have a large sample size. How large is large sample size, more than 30, remember? And then your data will follow a normal distribution, then you automatically know you will need to perform the z-test. Okay? So for a z-test, for you to determine the critical value is very easy. You just need to refer the standard table here. The value is already fixed. But let's say in the next few lessons, we will learn about t-test, ANOVA, and chi-square test, all these tests. This is not the same. You need to calculate your own critical value. But now we'll focus on the z-test first. Okay? So let's say for z-test, you know you are carrying out a z-test, and then you want to set your confidence level at, let's say, 95%. Okay? You want to have a confidence level of 95%. So your critical value will be 1.96. Okay? Always refer to this standard table. So now you've got, so with the confidence level of 95%, the corresponding critical value is 1.96. So now you got a population mean 35, you got the critical value. So this means that to calculate the upper and lower bounds of your confidence interval, when you want to come up with the range, we can take the population mean plus minus the critical value. So we'll get the intervals. Okay? But this is not the end yet. Remember, we still got step 3 and 4. Right? Next, you need to identify the standard deviation for your sample. Let's say I already provide you here the standard deviation, but everyone please learn how to calculate the variance and standard deviation covers in our descriptive statistics lesson, right? Okay, so let's say here the red color one is your standard deviation, 10 for year 1 and 5 for year 3. So you found the standard deviation for this study. And then next is the sample size, right? The fourth step is to identify the sample size. So what's the sample size here? It's 100 per group, 100 students per group. This is your N. Okay, this is your N. So now you got everything. You just insert all into the confidence interval formula. So this is the formula. Okay, to calculate, you want your data to be 95% confidence level. So for year 3 students, just insert everything. The confidence level will be the population mean, just now I mentioned. You can plus minus the critical value. And then you need to times, what's this? Remember the standard error? Remember the standard error we learned last week? For you to estimate the population parameter, you need to calculate the standard error. Only then you use the standard error for your z-score calculation. Remember that? So this is your standard error. You use the standard deviation over divide by the square root of your population size. This is the N. Okay? Then you got 0.5 and then you times with your critical value. Then you got 0.98. This is how you create the range, the interval. So for year 3 student, the lower bound and upper bound, you need to find the lower bound and upper bound. You just need to use 35, the population mean, minus 0.98 will be 34.02. Okay? Then again, you use the population mean plus this 0.98, then you get 35.98. Okay, so this is your confidence interval. Remember what does this range of value mean? So you set your confidence level at 95%. So no matter how many times you repeat your study, your estimate will, you are confident that your estimate will fall between this interval. Okay, this proves the accuracies of your study. Any question? Any question, class? Okay, so you need to do the same thing for year 1 student. You need to come up with the confidence interval. So it's the same thing. You use the population mean plus minus the critical value. Okay. 1.96 and then times the standard error. So this one you got 1.96. And then you do the same thing to come up with the lower bound and upper bound. Okay? So how do you report your confidence interval in a study? Okay, you can make a conclusion saying that we found that both year 1 and year 3 students with average 35 hours of television watch per week. So although there was more variation in the estimate for year 1, we can see that for year 1, this value is 1.96, but for year 3 it's 0.98 only. So it's higher variation in year 1 than for the year 3 student. And then you can put a bracket, confidence level 95%, and then confidence interval equals to the lower bound and upper bound. This is how you report your confidence interval, okay, in your study. Okay, so we mentioned here more variation. Remember, the critical value is to show you how far is it from your mean. Again, we're back to the standard deviation. Okay, so if you use the upper bound, lower bound, this value, as well as the population mean 35, you draw a box plot out. So you can see something like this. Okay, you can make direct comparison. Although they have the same mean value 35 here, but you can see year 1 has higher variation. Am I right? So this is how your box plot will look like with 95% confidence interval. So this confidence interval gives you confidence that if you repeat, again I repeat, if you rerun your study, all the estimate will sure fall within this interval. Okay? For year 1, for year 3 student, it's the same. Any question? So, what's the importance of confidence interval? So to sum up confidence interval, now you know the concept, you know the explanation, you know how to calculate the confidence interval with 4 simple steps, come up with the population mean, calculate the critical value, okay, and then calculate the standard deviation of your sample, and lastly identify the sample size so that you can use the confidence interval formula to calculate the CI. Okay, so again, confidence interval, remember, is a range of value. The probability that the population mean lies within this range. So the confidence interval measure the uncertainty in your hypothetical testing. Okay, a narrow confidence interval is desirable because it's lower variation, right? It provides a reliable and specific result. The smaller the range, the more precise. And the confidence, remember that the confidence interval cannot tell you how likely is it you found the true value of your estimate, because it's based on the sample, not from the full population. Okay, just for you to know, it's not the true value. Remember that it's not the true value. Let's say you already calculate the estimate. Let's say is just now our population mean 35, and then your estimate is 35. Let's say so, but this doesn't tell you the true value. Okay. Confidence interval only tells you what range of value you can expect to find if you redo your sampling or rerun your experiment again and again in the exact same way. Okay? Just remind yourself. Okay, so now we know what's confidence interval. Then, you also need to understand what's degree of freedom. Because in last week, we learned about the estimation. So estimations, we have 4 important things. when you do the estimations of population parameter. First is the central limit theorem, and then you calculate the standard error. Now you know what is about confidence interval and how to calculate confidence interval. And the last thing you need to know about for these estimations of population parameter is the degree of freedoms. Okay? So degree of freedom in an estimations of your population parameter by calculating the sample statistic, the number of independent pieces of information used to calculate the statistic, we call it as the degrees of freedom. Okay, so the degrees of freedom of a test statistic determines the critical value. Remember what's critical value of the hypothesis test? The critical value is calculated from the null distribution and is a cut-off value to decide whether you need to reject your null hypothesis. It's complicated, right? So next we will see step by step what's the degrees of freedom. So there's a standard formula for you to calculate the degrees of freedom. But it's also very simple. You just need to use the sample size. Let's say there's the previous example is 100, right? Minus R. So what's R? R is the number of restriction, or you can say R is the number of parameters estimated. Okay? So the degree of freedom cannot be negative. Please remember that. Your degree of freedom must always be a positive value. So the number of parameters that you estimate cannot be larger than your sample size. Okay? So it's very difficult for you to figure out what is the R, right? Okay, the number of restriction. R is the number of restriction or number of parameter estimated. So actually, the statistician already come up with a standard table. Okay? So it depends on the R, the number of restriction, depends on what kind of test you are using. Then you will use the formula to calculate your degrees of freedom. Okay? But in a z-test, we have, in various statistical tests, we have only learned the z-test. We haven't gone into the t-test, the independent sample t-test, dependent sample t-test, etc., etc., which we will cover in our next few sessions. So for a z-test last week, we didn't talk about degree of freedom because z-tests don't need you to calculate the degree of freedom. So now this is just for you a concept, what is degree of freedom, before we move into the t-test, which we will learn next week. Okay? So remember, when you want to calculate your confidence interval CI, you need to come up with a critical value. Okay? So, but when do you know you need to perform a z-statistic? Always remember when your sample size is more than 30, and then it will be normally distributed. Then you know you need to perform a z-statistic. But if that's not the case, let's say sometimes your research will have limitation. You cannot get really large sample size, so it will be less than 30. So if, let's say your sample size, you can't get a large sample size, then you cannot perform a z-statistic. Okay, you need to go for a t-distribution instead. So if for t-distribution, for you to calculate the critical value, you need to know the degree of freedom. Okay, the degree of freedom need to be included in the confidence interval calculation. But we'll learn that next week. How do you calculate using the degree of freedom? Okay? Okay, any question? Yeah, this is not in the slides. Great, you notify. Yeah, you. So I will upload these slides. Or do you already take a picture of it? Or you want the slides? Okay. No, why I remove it from your slide is because I want you all to pay attention. Okay, but I will upload it after this lecture, okay? So back to my question. Any question about the estimations of population parameters? No questions. So just now, we didn't do a recap or a summary, but now let's do a summary of what we have learned so far. Okay, again, in a scientific investigation, start with a research question, okay? And then you need to design your experiment, come up with hypothesis. So today, later on, we will learn how to formulate a null hypothesis and an alternative hypothesis, okay? And then you design your experiment, collect data, and you perform the descriptive statistic part. And for the inferential statistic part, what we have learned so far is that you use the sample statistic to calculate the estimate, and then to do the estimations on the population parameters. So what is important in an estimation? Last week, we talked about the central limit theorem, how to calculate a standard error. Today, we learn about the CI confidence interval, as well as the degrees of freedom. These are 4 important things when you want to do an estimations of population parameters. Okay? After you have all these things, you can start with your hypothesis testing. How do you test your hypothesis? Whether to read here. Earlier, you already formulate 2 hypotheses, right? So to test your hypothesis, whether you want to reject or accept your null hypothesis, you need to perform various statistical tests. So the real statistic starts today, last week. We learned about z-test, and then actually we will also learn t-test, ANOVA, and chi-square test. Okay? Any question, class? Okay, before we go into this objective 2, I will give you all the eye-checking code first.
Hopefully it does.
Okay, so for the checking code is 45657. 45657. Four, 5, 6, 5, 7. I repeat, our checking code 45657. Okay, so now we'll move into how do you test your hypothesis. Okay? So first, what's a hypothesis testing? So hypothesis testing is a formal procedure for investigating our idea about the world using statistics. So again, this is the 5 main steps. So you need to perform statistical tests, come up with a p-value, set your own confidence interval and see if your p-value larger or lower than the confidence interval, then you can decide to reject or accept your null hypothesis. Okay? So what's important here is the p-value. Okay? So there are two main hypotheses, the null hypothesis and alternative hypothesis. So a null hypothesis always predict no true effect, no relationship between variable, or no difference between group. It's always a no. Okay? Whereas for an alternative hypothesis, you state that your main predictions of a true value, there is relationship between variable, there are differences between your group. Okay? This is the difference between a null and an alternative hypothesis. So now, did you learn about how to formulate the hypothesis in the first lecture with Dr. Ravin? Or this is the first, oh, you already learned that. Okay, so I will speed up. So how do you formulate hypothesis? So let's say here, you design an experiment to test whether actively smiling can make people feel happier. Okay, so to begin, how do you form your null and alternative hypothesis? So remember, the null hypothesis is always no difference. Okay, there is no difference in happiness between actively smiling and not smiling. Whereas for the alternative hypothesis is actively smiling will lead to more happiness than not smiling. Okay? So here's another example. Does two flossing affect the number of cavities? Remember, for null hypothesis is always no effect. Whereas for an alternative hypothesis, you can say that two flossing has an effect on the number of cavities. And here's another example. Does the amount of text highlighted in the textbook affect the exam score? So for a null hypothesis, it's always no effect. So no matter how many text you highlighted in your textbook has no effect on exam score. Whereas the alternative hypothesis, you will say that there is an effect on exam score based on the amount of text highlighted in your textbook. Okay, so everyone clear how do you form null and alternative hypothesis? Okay, let's say you already formed your null hypothesis and alternative hypothesis. So here's an example. A body height measurement obtained from 10 students. This is your raw data. So you want to test the hypothesis whether this sample, these 10 students from this SB10802 cohort, this student population, where the population mean is 160, the standard deviation is 7.8. So what's your null hypothesis for this study? Anyone want to try? Null hypothesis is always no effect, no difference, right? It's a no. So you can say that your null hypothesis, the population mean is 160.05. So it will be the same as your sample mean. There's no difference. Okay? But for your alternative hypothesis, you will say that there is difference between your population mean and the sample mean. The sample mean, which is the mean from these 10 students. Okay? So this is your hypothesis. And then you perform, what do you do next? You perform statistical tests. So this is very simple, you calculate the average. And then you find out that the sample mean is 161.05. So what do you do? Is it the same or is there any difference? If this is your answer, 161.5, you cannot directly reject it, although it's not the exact same figure with the population mean, but you cannot directly reject, oh, this is This is not the same from the population mean. Okay, what you need to do? You need to set a threshold. Okay, you need to set your objective criteria. So let's say the green one from this graph, the green one is the population mean. And after you do the calculation, do the statistical test, you got 161.5, let's say it's over here. This is your sample mean. And then let's say if you set the threshold over here, and your sample mean is still within the intervals, right? So if it's still within the intervals, then you need to accept your null hypothesis. Okay? So you need to accept your null hypothesis. The sample mean is equals to the population mean. There's no difference. Okay? But if you're trying to be a little more stringent, you set a very small intervals, the threshold. So now you can see that if your sample statistic, the sample mean, now is outside the threshold that you have set. So if this is the case, then you need to reject your null hypothesis and support the alternative hypothesis stating that there is difference between your population mean and the sample mean. Okay? Understand, class? About hypothesis testing? Okay? Now we'll go into the calculation. How do you use your p-value to reject or accept your null hypothesis? And then how do you identify the sources of error? Okay? So first, what's p-value? We start to calculate p-value since 2-3 weeks ago. That's the p-value, the probability, remember? When we perform the z-test using the z-table, that's your p-value. So you will get p-value no matter you perform a z-test, a t-test, a chi-square test. That's your p-value. This p-value will help you to determine whether you want to accept your hypothesis or not. Okay, so it's very important. So this is a repeat of the last slides, whether you want to reject or accept your null hypothesis. Okay? And then here's the explanation for p-value. A p-value is a number calculated from your statistical test, as I mentioned, that describe how likely you are to find a particular set of observations if the null hypothesis is true. Okay? So p-value used in hypothesis testing help you to decide whether to reject the null hypothesis. So the smaller the p-value, the more likely you are to reject the null hypothesis. Okay? So, you know what's p-value, so what's statistical significance? So it's about all about concept today. So what's statistical significance? So a statistical significance is another way of saying that the p-value of your statistical test is small enough to reject the null hypothesis. Which means that when you reject your null hypothesis, you support the alternative hypothesis that there is significant difference in your studies, right? This is the statistical significance mean. Okay? So the statistical significance, or we so call the significance level, or in statistics we call it as the alpha value. Remember the alpha value? It's a value that researchers set in at once as the threshold for statistical significance. Remember the distribution graph just now, you need to set your threshold. Okay? So anything beyond the threshold, you will need to decide, or you can reject or accept your null hypothesis. Okay? And prove that there is statistical significance or no statistical significance in your studies. Okay? So if your p-value is higher than the level that you have set, the null hypothesis is not rejected. You cannot reject the null hypothesis, because in the last slide, the smaller the p-value, the more likely you are to reject the null. Okay, so if the p-value lower enough, the results are interpreted as reject null hypothesis, so your studies can be reported as statistically significant because you support the alternative hypothesis. So we keep on repeat that. If the p-value is lower than the significance level, the results are interpreted as you need to reject the null hypothesis and reported as statistically significant. But how low is considered low for your p-value? How small is a probability that will require you to reject your null hypothesis? Remember the alpha value, the critical value that we use in the calculation of confidence interval. So you need to set your own significance level before you start your statistical analysis, right? So the common significance level, the alpha value, the cutoff point, we use as 5%. But if you want to be more stringent, you want to be more strict, increase accuracy of your study, you can choose to use 1%, which is 0.01. But in usual studies, all the published study, we will go for a significance level, the alpha level of 0.05. Okay? So this means that everything, when you calculate your p-value, everything less than, let's say you set at 5%, everything less than 0.05, you can directly reject your null hypothesis. Understand, class? Okay, so this is a distribution curve here to show you. When you set the significance level at 1%, you want to be more stringent, 0.01. So which means that 99% of the value will be covered under this graph. And the remaining 1%, 0.5 over here and 0.5 over here, this is so-called the critical region, or we also call it as the rejection region. So if your calculation, your statistical test, the p-value, falls under this region, then you can reject your null hypothesis. That's why we call this as critical region. Okay? Or also can be known as the rejection region. Remember how to come up with the critical value? The table. You need to refer back to the table, okay? Is it clear, class? So, when you will need to use the significance level equals to 1, which is the alpha equals to 0.01. This is very strict, right? This threshold is very strict. A, when the result have minor consequences. When the finding have major impacts. B. C, when we are not too confident. Or D, when we want to be more stringent in our testing. So the answer is there actually. I forgot to remove. So it's B and D. Why B? When your finding have major impact. What does this mean when your finding have major impact? So let's say you are doing a drug testing, a clinical trial is very important, right? The drug you need to use to treat, let's say, cancer patient. You need to use it on human. So you want to be more stringent. Okay, you don't want to have any false positive. You don't want to have any chance to get false positive result. So you tighten up your threshold. So you set in your statistical test, you choose to use 0.01. Understand, class? Okay, so now we move on to reject or fail to reject your null hypothesis. Fail to reject is you need to accept your null hypothesis. So as I mentioned just now, if the sample provide enough evidence against the claim that there's no effect in the populations, then we can reject the null hypothesis, which means that your p-value, always remember your p-value smaller than the significance level that you have set. Let's say in most cases we will set it at 0.05. Okay? Then you will need to reject the null hypothesis. Or you can say that you support the alternative hypothesis. So, can also think of it as an estimate of the probability that a particular result could have occurs by chance. So this is your hypothesis. Okay, so if after you do the calculation, the p-value is lower, the probability that your observed value is due to chance is low. Okay, remember, but how low is low? You need to set a cutoff threshold, alpha value 0.05. Then, if you do the calculation, the statistical test, and your p-value is lower than the alpha value, so what does it mean? Go back to the question again. An estimate of the probability that a particular result could have occurred by chance. So, when your p-value lower than the threshold value that you have set, you need to, what do you need to do the first step? Reject the null. So this is not you want to support this statement. So what's the answer? The statement said is due by chance. So the result is unlikely to be due by chance, and the result is likely to be due to the scientific treatment or observation. These are the correct answer. Okay, when you reject the null. Everyone clear? Okay, so now you know the importance of p-value, okay, for you to test your hypothesis. But how about errors? So let's say we use the example, the height example, 10 students from the SB cohort, the population. So if your conclusion is you don't want to reject your null hypothesis, which means that you set the threshold that the sample mean falls within your intervals. So you do not reject, you accept your null hypothesis. The population mean is exactly the same, is the same as your sample mean. This is what you can say, right? But is it possible for you to make an error in this conclusion? Let's say now I give you the value, so you can see directly it's actually not the same, but you conclude that because you set the threshold is less stringent. So the sample mean actually falls within your threshold, so you do not reject the hypothesis. But is it possible to make error? Yes, right. So we have two types of error. If you reject your null hypothesis and your null hypothesis is actually true, then you will get a type 1 error. Okay? But if you accept your null hypothesis, and actually the null hypothesis is false, let's say this study. So your null hypothesis is they are the same, but it's actually the false, right? So you will get a type 2 error. So this is an example of a type 2 error we can see here. So what's a type 1, type 2 error? So in statistics, a type 1 error we'll call it as a false positive conclusion. So a type 2 error is a false negative conclusion. So the probability of making type 1 error is the significance level alpha, where the probability of making a type 2 error is the beta. We'll learn beta in T statistical test. Okay? But do remember how to differentiate type 1 and type 2 error, okay? Okay, class, clear? So here's an example for you to refer to. So if you are pregnant, then this is positive, true positive. But if you are not pregnant, But if you are pregnant, and then the doctor tells you that you are not pregnant, so it's a true negative. No, sorry, a true positive is you are really pregnant. Then a true negative is you are not pregnant, okay? But for a false positive type 1 error, the doctor say you are pregnant, but you are not pregnant. Okay? Whereas for a false negative, a type 2 error, you are pregnant, but the doctor tells you you are not pregnant. Okay? So type 1 error. Type 1 error, so we focus on only type 1 error in our Z statistic, which is the class for today. Okay? Type 1 error means rejecting the null hypothesis when it's actually true. The risk of committing this type 1 error depends on the significance level, the alpha level that you set, right? Am I right? So the significance level usually sets at 0.05. If you go and find some published paper when they perform the statistical analysis, no matter what test they do, they calculate the p-value, they need to set the significance level. And most of the paper will actually set at 0.05. Okay? This means that your result only have 5 chances of occurring or less if the null hypothesis is actually true. Okay, this is already enough for you for your study, 5%. Unless you need a more stringent threshold, then you go for 0.01, which is the 1%. Okay, so remember, any value, the p-value that falls in this region, what's this region called? After you set your confidence level, the significance level, let's say 0.05, so this is the 95%. This is the critical value. Okay, so this is the rejection area. Anything falls here, reject the null hypothesis directly. Okay? Understand, class? So now you learn the concept. You know what is hypothesis testing, how to formulate a hypothesis, how to test your hypothesis using the test that we have learned to come up with the probability error, and then to set the significance level, right? So now we learn how to test your hypothesis with a case study, okay? So now you want to study the effect of a new teaching method on test score. So the objective is to investigate whether the new teaching method can improve the student test score compared to traditional teaching method. So what's the hypothesis for this study? What's the null hypothesis for this study? It's always a no, right? So the new teaching method is the same as the traditional teaching method, no improvement in the teaching score, in the exam score. Whereas the alternative one is states that the new teaching method improves the student's test score compared to traditional method. Okay, this is the first step for your study. Then you perform the experiment, you start to collect the data. Okay, you start to collect the test score. And then you do the statistical analysis. So what's the first step? Remember last week's lecture, we need to just draw a subset from the populations. It's hard to get the test score from all students in Sunway University. So you draw a subset. Okay? So when you draw a subset of the sample, you need to start with the estimation. Okay? What's important in estimations of population parameter? 4 important things. The central limit theorem, the standard error, confidence interval, and what's the last one? Degree of freedom. Okay? So let's say here I give you the standard deviation test score 15. And then you have the mean test score for group A and group B. Okay, you have the standard deviation, you have the mean. Remember how to calculate standard error. This one we learned last week. If you forgot, you please refer back to our lecture note last week. But this is the step that you need to do in your assignment, okay? You need to start with an estimation, calculate the mean, calculate the standard error. Okay, then with the standard error, you can come up with then you perform a z-steady state, which is to calculate the z-score. Okay, then with the z-score, refer to the z-table, you will get your p-value. This calculation, I'm sure everyone is clear, right? Who still don't know how to calculate p-value? Please come to me after this, okay? So after you got your p-value, what we learned today is to test your hypothesis, you need to come up with the confidence level. Set your confidence level, okay? Alpha value equals to 0.05, which is 95% confident, okay? After you set your confidence level, you do the calculation. Come up with your p-value. So let's say for this example, the p-value is 0.0475. So it's smaller than your confidence level. So reject the null hypothesis directly. Okay? And then you can conclude that because for this study is based on the new teaching method. So you reject your null hypothesis, conclude that the new teaching method actually improved the student test score compared to the traditional teaching method. Okay? Okay, so next week we will learn about the z-test. The procedure is always the same. You start with the hypothesis, estimation, calculate mean, standard error, compute the t-steady state this time. Okay? And then you come out with a p-value. Always remember how to set the confidence interval for you to reject or accept your null hypothesis. Now you know the concept of why you reject your null hypothesis if your p-value is smaller than the confidence level. Okay? Everyone clear with the basic concept behind of this hypothesis testing? Clear? Okay. So today we have learned about confidence interval, how to test your hypothesis, and most importantly, what is important in testing your hypothesis is the p-value. And remember, the source of error, we have type 1 and type 2. Okay? Any question, class, before we move into assignment 2? Okay, so next Wednesday is the deadline for your assignment 2. Okay? Okay, so I received many questions regarding assignment 2. How do you do it? How do you write a standard report? What format is the report? But I believe all this already included in the instruction. You need to have your objective, like what I teach every time during our lecture. You need to have your research question, objective, then formulate the hypothesis. This is the full standard scientific report, okay? Remember to state all this. And then remember that this assignment 2 is not, the main focus of assignment 2 is to test your understanding on the sample, the effect of sample size. So, no matter what kind of data you use, you need to understand, you need to get at least 500 data sets, right? 500 data points of your sample set. And then you need to divide it into 5 groups. The entire population set with 4 subsets, right? So this is why we want to do this is to test the effect of sample size. So after you got the 4 subsets, you start the procedure just now. You do the calculation, come up with everything, confidence interval, hypothesis testing, p-value, z-score, z-steady state. Come up with a normal distribution graph. Okay, then you show me whether different sample size, you will get the same results or not. This is the goal of this assignment. Okay? It doesn't matter you get a COVID-19 data set or cancer treatment data set. It's nothing to do with your discussions on how importance of your data sets, okay? It's on the sample size, to test your understandings on your sample size. So I give you an example here. I'm using the Palmer-Penquin's data set. So we want to test whether each subset of the data, the mean of this variable. So I simplify it. Although I get a complicated data online, I simplify it. I only want to test whether the mean of this variable, the flipper length, is significantly different from the populations. Okay, you have 4 subsets. You calculate the whole thing, then you compare with your population mean. Okay, then you do the discussion. So let's say you got a population mean, this is the most important thing, the starting point, and then form your hypothesis. I'm sure everyone knows how to form your hypothesis. Then, okay, what to include in your methods and results. So I received these questions also. In your methodology, you need to describe your data set. Although I mentioned that the nature of your data set is not important, but you need to show me where do you get your data set from. You need to do proper citation. How do you separate the data set into 4 subsets? Okay? And then, how do you describe your subsets of data? So for each subset, how do you calculate the descriptive statistic, standard error, sample size, degree of freedom if applicable, but we are doing a z-test, confidence interval, and then how do you find the p-value? All these are under the methodology. Okay? You need to show me step by step. Then compare a p-value with the significant level. You start the hypothesis testing. So this is your results, methods and results part, okay? How you get the results, you need to show me. And most importantly is the discussion. Remember, please answer these 2 questions. Discuss how the sample size affect the descriptive statistic, your histogram, the CI confidence interval, and the hypothesis test results. So let's say maybe for the statistical test for the entire population, you actually reject the null. Okay? But who knows, maybe in your 3rd subset, because of the sample size are too small, you might need to accept your null hypothesis. So discuss this. Okay? Then evaluate the appropriateness of using normal distribution to model the data set. Any deviation from normality in the context of different sample size. Remember, when sample size increase, your data set will be normally distributed. Okay? So everything is covered during our lecture. So clear about your assignment 2? Okay. Any question? Okay. No question, then I'll see you all next tutorial, next Monday to Wednesday.
Monday to Friday.
Next week also got a lecture, yeah.